Okay, so this talk is really going to just throw a lot of stuff at you. I'm not going to go deep into anything. What I really like about conferences is coming out with little things that I want to research later, right? So I'm not going to go into a lot of depth about anything, but I'm going to talk about Git. So a little bit about me. As she said, I was one of the co-founders of GitHub. I wrote the Pro Git book, so if you go on the Git website and read sort of the documentation, I'm to blame for most of that. If anything's wrong, which there are wrong things in there, I apologize for that. And now I'm working on a new Git GUI called Git Butler, which you can go to gitbutler.com and try that out and download that. I'll talk about it a little bit at the end. But most of this is going to be about just plain, pure, vanilla Git. How many of you use Git on the command line? How many of you use Git as a GUI or in an IDE or something? Okay, so it's mostly command line stuff. So how well do you know Git? There are a lot of Git commands, right? So there are 82 what they call porcelain commands. So this will be things like your main, there are 44 main commands, add, commit, push, pull. Most people that I meet probably learn like 8 commands, and they really only use those 8 commands over and over, and most of the ones that you've memorized and use on a daily basis are probably in those 44. But there's a lot of other fun stuff in there. There's manipulators, and you probably use config from time to time, or when you first set it up, reflog, replace, things like that. There's interrogators, there's things that kind of go through your history, like blame or re. There's interactors, like send email, perforce, subversion bridges. There's a bunch of stuff that none of you have probably ever used, but they do exist there for interacting with other systems. And then there's a bunch of plumbing commands. And there's a whole bunch of really weird plumbing commands that I actually use a lot because I'm working on a Git GUI, so I have to kind of go in and see what the objects look like and things like that. But for the purposes of this talk, of the 145, I'm not going to go through any of those. That's a completely separate talk that I would love to do, but it is a level of nerd that I'm not sure that I can hit right now. So what I want to do is go through Git, because most of us, I've been using Git for almost 15 years now, a little over 15 years now, I think. I'm very old, but so is Git. But most of what I do on a daily basis, most of what you guys do on a daily basis is probably very not different than what I did 15 years ago, right? You're still doing adds and commits and pushes and pulls and fetches and stuff like that. So, but it's a very active project, right? There's still almost 10 commits a day, 10,000 commits in the last 3 years. So what has been happening? So what I really want to do is kind of go over that. So this is our agenda. We're going to do some helpful config stuff. We're going to do some oldies but goodies, some stuff that's been around for a while that you may not know about that I find very valuable, that are not defaults. We're going to go through some new stuff that you may not have noticed that have happened in the last couple years, or sometimes in the last couple months for some of them, and some big repo, monorepo stuff, which I find really interesting. Git is actually very good with large repositories now, which didn't used to be the case. And then I'll show a couple of new GitHub stuff and some Git Butler stuff. So again, like I said, I'm just going to shoot a bunch of stuff out at you. It's going to be rapid fire. Take what you want. If you don't want to take notes, you can go to the blog of my company, blog.gitbutler.com, and I have these slides up, so you can go through any of them. And there's also a previous recording of this talk if you want to watch it again. My jokes are better in that one. So let's start with some helpful config stuff. So a lot of you may know about aliasing. What I'm going to talk about a lot in the later parts, the reason that I put this in is because I'll talk about a bunch of like command line options that you can give to some of the commands, and usually you don't want to type out all of those command line options. So if you find any of this useful, what you probably want to do is set up an alias, and this sets it up so that you can run, in this case, git stash with 2 A's, and it runs a little bit of a different git stash command, right? So if you have things that you like using, you can set up an alias, and then it just sort of expands that alias out as though it's a git command. So in this case, stash dash dash all will do a slightly different version of stash, right? So if you like using that, you can set that up. But that runs for just about any of these command line options. You can also write your own scripts that do stuff in Git, and you can alias it with a bang in the front. And then if I run git bb, it will run this shell script, right? And so if you want to write your own sort of Git commands and pretend like they're Git commands, you can reference your own program that way. So this is an example. If you go to my gist, that I run git bb, and it kind of gives me a different version of it shows branches in a different way. So I don't really like the default way that Git shows you branches. I think it's like an alpha ordered and all in one column. So for this is nice, I have ahead behind information, which I find very valuable, like GitHub does and really Git almost never does. and then show the branches, but then it orders it by the last commit, and it also I don't know if you know this, you can put notes sort of on branches, but they're rarely shown or used for anything. So I'm actually pulling them out and showing them on the thing, so you can kind of say, this is what this branch is doing, which is kind of nice as well. Okay. The other config thing that I want to share is these conditional configs. So a lot of you are open. Raise your hand if you work on open source projects. Okay, so a lot of you work on open source stuff and have a day job, and sometimes they don't entirely overlap, or you work on them at the same time. One thing that you can do is, you may know that Git will look for configuration values globally, right? So it'll look in your home directory for your config values, and then you can overwrite them on a per project basis. But you can also overwrite them in a subdirectory. So every project in that subdirectory can look, so it'll look in the project, and then in the subdirectory, and then in the global configuration. And so if you want to put, say, all of your open source stuff, you have an open source Git config, and you have a work Git config, and you put all your projects into your work projects under work and your OSS projects under OSS. Whenever you do commits and stuff, it'll use those configuration values for your email address and your name and stuff like that. So if you want to, if you have stuff you don't want people to know who you are, right? You have a pseudonym or something, you can do that. So here's a simple example, right? Under OSS, I have a .git config. I put in that if include value, and then when I'm under there and I run git config, it shows this, and when I'm under OSS and I run git config, it shows another one, so when I do my commits, it uses those email addresses. So that's kind of nice. Okay, oldies but goodies, a bunch of stuff that Git has done for a long time. One is git blame. How many of you use git blame? I blame files all the time. You can run -l, which limits the scope of what it blames to a certain section of files or a certain function, or a certain line range or certain function. So you don't have to blame the whole file. You can say, I just want to blame this particular thing. So -l is just blame a little. So you can say -l lines 15 through 26 on this file, and it will just give you that. You can also run git log -l with the same thing, and it will essentially give you the same information, but in a format of a log, right? So it'll show you the same listing of commits, but it'll say, here's the last one that was done, and the one before that, and the one before that, but only stuff that touches those lines. And so it's kind of a nicer way. If you want to say, what's the story of this function, sometimes the log blame is kind of a nicer way of reading through that story than just seeing sort of the top line commit message of every line over and over and over again in some cases. You can also do this kind of interesting thing where you do a colon and then a string, and it'll try to figure out what you're talking about, right? So if you do a colon and then a function name, and then another colon and the path to the file, it will try to figure out what function you're talking about and figure out the line range for you, which is kind of cool. Okay, but git blame is kind of stupid in lots of cases, because it will just show you, if you take a function, you move it to another file, or you rename a file, it will just see that rename, or just see that, or if you get a new person that you just hired, and they come in and lint all your shit, and now every line is owned by them, there's a couple different ways that you can solve that. One is, there is I forget the name of the file, but you can put in a thing that says ignore these commits, and blame will just ignore them. I forget what that is. I should probably put this in the presentation at some point. But the other thing you can do is give blame a bunch of options. So one is -w, which is ignore white space, and then you can do -C, which detects lines that are moved or copied within the same commit. So if you move something and then commit it, it will ignore that movement, right, and just kind of go back to whatever it sees the movement of the file. So it's kind of nice. One of the things that Git does that I don't think I've ever seen a Unix command do is, if you give it the same option more than one time, it does more things, right? So if you do -C twice, it will detect lines moved, or in the same commit, or the commit that created the file. If you give it 3 times, it will do any commit at all, right? So each one of these makes it more expensive, but filters out more crap, right? And so then what you get, if you run, let's say this blame, where I can see on this particular, TypeScript class, it looks like Kirill did all of this work, right? If I run it with 3 capital C's and a -w, then what it does is I can see that Kirill actually wrote almost none of this code, right? These were all written by other people, but we had a lot of refactorings that kind of moved them around, and it will show you, it will show you what file that change was made in at the time. That file may not exist anymore, but that was the file that was edited at the time that there was a last meaningful edit of that line. So this is a much nicer blame. I would suggest setting up an alias for this if you're using. I always run git blame with this by default because it's almost always more valuable than a normal blame. Okay. The next one, oldie but goodies, is the pickaxe. So if you do -S, you can search for regexes in the patch that any particular commit is introducing. So if you want to see where something was removed from your code, if you remember that I had written some function and then somebody took it out and then you want to go back and find it again and you remember what the function name or any string in any of the code, you can do -S. I don't know why it's called a pickaxe actually, but people on the mailing list call it a pickaxe. But I can search for a string, or you can also do a regular expression. There's some other cool things that you can do with this type of functionality, but if you look through the docs for pickaxe, it'll show you stuff. And I can go through and say, okay, here's when any commit either added or removed lines that matches files watcher, right? Which is kind of nice. One of the last ones, git diff. By default, will do these lines. So it'll say, you removed this line and you added this line, right? What I really did was I changed a word in this sentence. And it's a little bit difficult to parse this. Now, GitHub will do both of these. So if you look at the diff on GitHub, it will do the line, and then it will also highlight the word that was actually changed within that line in some cases. But on the command line, you can do this as well with --word diff, and it will just it'll do this kind of weird thing here. But it's much easier to kind of parse the change in that line that way. Another thing that most of you should probably, if you do, who rebases their work a lot, like their branches? Okay, so if you're doing rebasing and you don't have this turned on, you should probably turn this on because there's almost no downside to this, and it can be very helpful. Re stands for reuse recorded resolution. So anytime that you do you get a merge conflict and you fix it and you commit it, it remembers that change. It remembers, okay, here was side A and here was side B. And here's how you committed the resolution. And the next time it sees it, it will say, hey, I remember this. Do you want me to just use what you did last time? And it'll use what you do last time. So you don't have to do the same resolutions over and over again. So if you just set it with this sort of global re-enabled, it will start doing it automatically. So if I get a merge conflict, it'll say, hey, I recorded the pre-image, so I remember what this conflict looks like. And then you commit it, and it says, okay, I recorded the resolution. And then the next time that you rebase something or you merge something and it sees it again, it's like, hey, I saw this, and I automatically staged the resolution, so it doesn't even show it as a problem at this point, right? So that's kind of nice. Okay, that's all the oldies but goodies. Git has done all of those things for a very, very long time. How many of you learned something new in that section? Awesome, okay. So, some new stuff. So, I mean, if you guys didn't know that stuff, you're not going to know this stuff. So, a lot of this stuff some of it is brand new, right? So, this is dumb, but I like it for two reasons. One is that it's dumb, and the other is because it's somewhat useful. If you run git branch -- column, instead of listing the branches out as one sort of line, or one branch per line of just here's all your branches, right? Like git branch -- r or whatever. This is what it normally looks like to say, okay, this is the branch you're on, and then here's a bunch of other branches and so on. If you say -- column, or you set this config value, column.ui is auto, and the other thing you can do is set a default sorting, so you can do branch.sort, and this is by reverse committer date. So it will not sort them alphabetically, it will sort them by the most recently committed to first, right? And sort of order them, which I find this much, much more useful. Then it'll show it like this, right? So it'll break it into columns. It'll automatically kind of figure out the longest name and say, here's a column format of this, and sort it by last committer date rather than alpha order. But what's very funny is that the way it does this is it pipes it through a new Unix command that Git ships with called git column, which has nothing to do with Git. All it does is take text input that is sort of one line and then tries to put it into multiple columns, right? So you can actually use git column through anything. If you have any output and you pipe it through git column, it'll give you a nice sort of UI formatted textual representation of it with padding and stuff like that. So this is a tool you have on your command line right now. I don't know if you know that, but I find it very funny. Okay, the next one is -- force with lease. Show of hands, who uses force with lease? Okay, then this is really, this should probably be the default in Git, honestly. So here's what the problem set is. I'm sure everyone in the room has run into this. There's Scott and Tom. Scott makes some changes to a file, commits the changes to the file, pushes it to the server. Tom pulls those changes down, gets the new changes to the README. Then he makes some changes to the file, and he commits, and then he pushes, right? Totally normal so far. Scott goes to lunch, gets some Aperol Spritz over here, next to the thing, gets a little drunk, forgot what he was doing, comes back, says, oh, man, I forgot. I wanted to do this. I'm just quickly going to amend my commit, and then I'm going to force push that, right? So this because, this happens. So fine. Now Tom, has to deal with this at some point later. What you can do, in case you just want to be safe about it, is you can do force with lease. And what force with lease does is it looks at what your local representation of origin master, so the last time you pushed or fetched, and make sure that that matches what's on the server. And if it doesn't, then it refuses to push, right? And so this is just, it's nice, right? It gives you an idea that, because this can happen real fast, right? Like you can do a fetch and then make your change and then do a fetch again. And then in the time it takes you to write like git push, somebody's pushed, right? And so it's kind of nice to just have this thing in there that you don't kind of screw it up. There's also another command called force if includes that is even stronger, right? So if you happen to have some background fetching thing or something like that, or you fetch in the meantime and then you push, it will match, right? And it'll force push it. Force if includes looks through your ref logs and make sure that you actually merged it at some point or that it's in the history of the branch that you're trying to push. So it's even safer, but it won't work unless you also do force with lease. So if you want to be very safe with your force pushes, you literally have to type out all of this stuff, right? So this is where the aliases kind of come in handy. The next one is Git maintenance. Sorry, I just want to keep doing the show of hands because I'm curious sort of what the state of the art is, especially in different communities. Who uses Git? Who knows what Git maintenance is? Okay, so what I want to encourage you to do is go on your laptop and type Git maintenance right now on whatever projects that you use a lot, because all it's going to do is make everything faster. If you type Git maintenance start, what it's going to do, sorry, not Git maintenance, Git maintenance start. All it's going to do is add in this config, this little config value into whatever project. And what this does is a whole bunch of stuff, right? It changes sort of the defaults for commit graph stuff, for prefetching, for how it packs loose objects, how it does incremental repacks. I'm going to go into the important ones of these a little bit later, but essentially what it does is set a whole bunch of values that try to make a lot of stuff that Git does faster behind the scenes that you don't really have to worry about. So I'll get into what those are in 1 second. Work trees. So one more time, who uses work trees? 1, 3, okay. So work trees are when you want to work on multiple branches at the same time. Now there's a couple different ways you can do this, right? And so this is the alternative to, say, stashing a work in progress and checking out another branch and working on that and pushing it up and then sort of stashing back what you had, or doing a work in progress commit or something and switching back and forth between branches. What you can do is have multiple subdirectories that have different branches checked out on them. So you could do this by cloning. You could clone to 2 different projects, right, and be in different branches. Or you can even clone locally. So you can, I don't know if you know this, you can clone clone / my project name, and then it puts it into a second repository, and then the remote, if you push, goes into the other subdirectory, right? But this is kind of cooler because it kind of does that, except it uses the same object database. So any work you do in any of the work trees of your project is seen globally by all of the other work trees, right? So if you commit on a branch and then you go to another work tree and you say, hey, what are my branches? It's going to see the work that you did in the other subdirectory. So you can have lots of different working directories that have different branch states on them, and all the work is seen by all the other ones. So if these are our branches, if we have my patch series and we have main, and we want to check out a new branch, but we don't want to stop kind of what we're doing, we can say add git worktree add and give it a subdirectory and give it a branch name. So in this case, bug fix. Or you can just check out the branch you're on and then go over there and switch if you want to. And then if we go into that working directory and we make some change and we do a commit, and then we go back to our other one, we can see, if we want to get branch, that we see the branch that we were working on in the other one, right? So it has this sort of shared state. And it also shows it a little bit different, so you know that this is in a work tree somewhere, which is kind of nice. And then if you want to see what your work trees are, you can say work tree list, and it will say in any of the work trees, and it will say, here's where all of the different branches, the different work trees of this particular project are, and you can go and work in any of them if you'd like to. And if you delete it, you can say work tree prune, and it'll just delete the references that don't exist anymore. Okay, Fixup commits. So if, for those of you who raised your hand when you were doing rebase, if you rebase sort of a patch series a lot, this is a really, really nice tool to help manage that. And so what it does essentially, so the concept is, let's say you have a couple of, actually I probably have a thing for this. The concept is, let's say I have a patch series, right? So I have these 5 patches in some branch or something. And I send them to GitHub, and somebody gives me feedback and says, okay, here's the changes that I would make. Change the documentation in some way, and change the client-side thing, and change the test of the new feature. And you're like, oh my God, right? Because now you have to do sort of an interactive rebase and stop at each of those points and commit stuff or whatever. So what this does is help make that process much, much easier to kind of squash those changes down into those commits. So in this case, let's say we want to edit the documentation, which is way at the bottom, right? So an interactive rebase, we'd have to kind of go down there and do that. What it does is you say, hey, here's my change, and I'm going to do -- fixup. I'm going to commit it, but I'm going to do -- fixup with the target of where it goes, right? This is the one that I'm supposed to be changing. And so I can do that several times and say, I can even do them to the same commits, right? I can say, here's the change, it goes to this commit. Here's a change, it goes to this commit. Here's a change, it goes to that patch. And then, I zoomed in case anybody's particularly blind. And then, now we can see what it did is it gives us a new commit on top. So this is mostly how how people using GitHub kind of do PRs, right? Is they're like, I fixed some stuff, and then they push it, and then GitHub PR is like a unified diff, and you're like, okay, I guess that's fine. But then when you blame, you kind of come up with fix some stuff, right? Which is not as valuable. So in this case, it does a specific message, and if I run rebase. Either interactive rebase and I do, or just rebase without interactivity now. This is actually a newer one. You used to have to do it with interactivity. So if you have a very new version of Git, you don't have to do the -i. You can just say -- auto squash, and it's going to take your patch series, it's going to rearrange them, and it's going to do the proper squashing, right? So now it's taken that top one, and you can see it's changed the SHA here, right? And then rebased everything on top of it. But it took that change I made and it squashed it down into this commit. So it's a nice way of handling sort of rebase series. Okay, big monorepo stuff. So if you happen to work with very large repositories or monorepositories, Git has some really nice tooling for this now. It used to be very bad at this. It used to be essentially anytime you clone like the Linux kernel or something, you'd have to get the entire Linux kernel. You couldn't really make like just check out this directory or just get some smaller version of this that I can work on. Most of this has come into Git because of Windows, because Microsoft tried to move or has effectively moved their Windows team to using Git. So Windows is written in Git now, which I'm not sure if anybody knew that, but that is completely ridiculous to me. But in order to make that work, Windows is a very, very, very large database, right? So they have 3.5 million files in a checkout. And it's 300 gigabytes. So you can imagine trying to clone, like it's your first day at Microsoft and you come into work on Windows and they're like, just run this command and then go to lunch and we'll see you tomorrow. And you can start working on it tomorrow. There's also 4,000 engineers working on it every day, right? So there's a lot of overlap. There's a lot of work going on. So in order, again, in case I didn't say that correctly, here's some numbers that I just said. In order to fix this, what they did was they tried a couple of different things in series that kind of worked around and on top of Git. The first was a virtual file system, which is similar to how Facebook uses Mercurial. They have like a virtual file system that Mercurial uses in order to make this type of large repo work doable. And then they moved that into, they didn't really like the way that worked, and so they moved that into a project called Scalar, which kind of worked on top of Git, and specifically on Windows. And then they backported all of that into vanilla Git. So now everything that was in Scalar is in Git, and you can use all this stuff. So one is prefetching. So when you run git maintenance start, one of the things it runs is every once in a while, it will fetch from the server. It will not fetch your refs. It will just fetch the data and keep them in hidden refs, so that when you do a fetch, it will update all of your refs, but you already have all the data. So the fetch looks like almost a no-op, right? It'll be like, hey, like I want to fetch this thing, and it's like, this is where the heads are, and it's like you already have all these objects, so it's instantaneous. You can look at them if you do for each ref and look for prefetch stuff. They're under this ref's prefetch, not under ref's heads, but it downloads all of this stuff in the background, so you don't have to think about it. It also writes commit graphs, which is like a little database that makes walking the commit history faster. So in this case, if you have a really large repository, a git log -- graph, before it renders anything, it's going to take like 10 seconds because it has to go through and figure out what the graph looks like before it can show you the top line. If you write the commit graph out, it kind of just takes the commit data and the walkability and puts it into its own little data file and keeps it up to date. And then the next time you run it, it's still slow, and then the next time you run it, it's incredibly fast, right? And so again, git maintenance start will just do this on fetch all the time for you. So all of your ref lock or all of your rev walking stuff is just much faster out of the box, and you don't have to do anything with it. You can turn it on like this: fetch, write, commit graph true, or you can run the git maintenance start thing. The other thing is, if you have a lot of files in your working directory and you run git status, it has to stat every file to figure out what the M time is to see, did this file change? But with git maintenance start, with the file system monitor, it will run a daemon in the background that looks for inode changes and will keep a cache of that, so it doesn't have to stat every file. So this is part of the way that how they got away from the VFS stuff is to make this fast. So you can turn this on with core.fsmonitor true, and then essentially the next time that you run git status, it's going to fire up this daemon in the background, and it'll sit there watching your file system and keeping this log of when you run git status, it becomes much faster. So this is a 11-second git status, right, on a large checkout, and then I turn the FS monitor on, and again, the next time it's not that much faster because the file system monitor has to fire up, and then the time after that, it's half a second instead of 11 seconds, right? So if you have a lot of file checkout, but even if you don't, it's still faster. So you might as well, unless you really don't want the daemon running. This is on Chromium, so it's 500,000 files. And then the last one really is partial clone. So if you want to clone the Linux repository, it's 4.5 gigs, right? So it's not nothing. It takes a little while. You can do this thing called filter blob none, which doesn't give you any of the file contents. It just gives you the commits and the trees, right? So if you do this, it's just going to get the stuff you need to sort of check out a working directory, but it won't give you all the other files in the history. It'll just leave them on the server. So if you do blob none, then instead of 4 gigs, it's 1.5 gigs, and it takes much less time. It has to do 2 fetches, though. It has to do one for all the commits in the trees, and then a second one for all the blobs for your working directory so that it can populate your working directory. You can keep going and say, don't give me any trees either, which doesn't give you any of this stuff. It just gives you all the commit data and then whatever it needs to check out the head. And this does 3 fetches, but now it's only 600 megs, right, rather than 4.5 gigs, and it goes much faster. The downside of this is that if you run a blame, and actually kind of the cool thing, if you run a blame, it doesn't have any of those file contents, right? So it can't really do a blame effectively. And so what it does is it just keeps fetching every object that it needs. As it sees that it needs it, it will fetch it from the server on demand, right? So in this case, on the Linux kernel, on this file, a blame was 4 seconds versus 45 seconds because it had to get every single version of the file that it thinks that it needs to look at it. But that only happens the first time. The second time you blame it, you already have all those things locally, so it's fine. There's a lot of other big repo stuff, and GitHub and Microsoft have blogged about this. If you're interested in any of this, it's kind of fascinating, but not a lot of you probably use that. And then the last thing from big repo is monorepo stuff. So if you use a monorepo, which is having all your projects in one repository, there's a sparse checkout that you can say just check out these 2 subdirectories of this large project or something like that, and then all of your commits and stuff, your statuses are all faster, your commits are everything's faster because you're working with fewer files, right? So if we look at a status that's 5 seconds, and then we run git sparse checkout set, and then the 2 subdirectories that I only want build and base, it'll take all the rest of the files out of my file system and let me just work with those, right? And then when you run stuff, it's like, okay, you're in a sparse checkout, you only have 2% of your tracked files, right? That's all you have on disk right now. And then finally, some GitHub stuff. So there's a lot of stuff on GitHub. I have been using GitHub for a long time, but I haven't worked there in a while. And setting up some new repositories, I've found some things that I didn't know exist. There's actually a lot of little triggers and buttons and stuff that you can do now that are interesting. One is allowed merge types. There's 3 different merge types you can do on GitHub when you hit like the merge button. But you can say which ones you want as an administrator to allow for your project, right? So you can allow squash merging, which is taking the whole branch and making one commit out of it, so you have a linear history. It takes the whole PR, so then it doesn't really matter if you're doing, patch management and stuff like that, because the whole thing's going to be smushed down into one that was like, this is PR 45, right? Regular merges, and then only allow rebasing, right? So it'll only rebase, when you hit the button, the only thing it'll do is rebasing. I have actually all of these turned on. You can say what the default message is for squash merging. I have all these turned on, so I can choose which one I want to do when I merge a PR in my project, but you can say only allow one of them, or only allow 2 of them, or something like that, which is kind of cool. There's also auto merging, which is one of my favorite features, actually, that's relatively new, which is if you have a bunch of CI running, and you have a PR, and you're like, if this passes all my CI, I'm gonna hit this button, right? And it's like, no, go get a beer, come back, make sure that CI is done, and then we'll let you hit the button. Until then, it's grayed out, right? So now they have this thing where you can say, you can hit a thing that essentially is a conditional merge, right? It's like, if it passes all the CI, then automatically merge it at the end of that process. And you can set which tests it's checking for in order for that to be true or not. I love this feature. I actually use this a ton. Linear history. For those of you that are rebase nerds that really love having a completely linear history, you can enforce it so people can't even push merges to the server. So one is turning off the merge button sort of on the UI. This one will actually stop it at the server level. And if it sees merge commits, it won't allow the push to happen, which is kind of cool. And you can also require signed commits and things like that if you use sort of GitHub as this massive GPG keyring, right? Which is doable. And then the other thing that I actually just used today was GitHub actually advertises all of the PRs, all of those heads as essentially pseudo branches, even ones that are PRs from forked repositories. And you can directly pull them in if you want to. So if we look at sort of the remotes, like this is some branch called inertia. If I look at all of them, though, on GitHub, it actually has all these refs pull, and then the PR number, and then the merge and head SHAs. So if I want to directly pull something in without kind of, to test it out locally or something like that, I can run git pull origin and just say pull my PR number and head, and that will pull it into whatever branch I'm in, or I can fetch it if I want to, right, and kind of take a look at it. But I don't have to figure out what the branch name is that the PR is based off of. I just need the number. And that's it. What I do, the project that I'm working on right now is also on GitHub. You can check out sort of the source code and look through it and test it out, which is a Git GUI. And it has another interesting approach to essentially the work tree problem that I was talking about before, except for instead of having all of your branches in different subdirectories, it solves the same problem, but it puts all of your branches in the same subdirectory, and we have sort of a smarter index and head system, right? So in this case, this is kind of what the GUI looks like. It's dark mode because we're cool. You can switch it if you'd like to, but each one of these lanes is a branch, and they're all essentially pseudo-merged into your working directory, right? So when you work, you can take a file and you can sort of drag it into another lane, and you can commit it there, and you can keep working and figure out where you want your changes to go, and commit and push them all independently, right? So if this is my feature implementation and this is my bug fix, you're working on a feature, somebody's like, hey, I have a bug, I need you to fix it. You don't have to stop what you're doing or stash stuff or something like that. You just hit a button, create a new virtual branch, do your work in there, commit it, push it up, and then go back to what you were doing without really changing your flow. And then when you push them, they go into sort of new branches on GitHub or GitLab or whatever you're using. Don't use GitLab. But they look like that was the only thing in your working directory at the time. So it's almost like interactive adding, but much more interesting and powerful. If anybody wants to talk about implementation of this is all in Rust. I'm a new Rust person. I'm forced to use it in order to get this to happen, but I do love talking about Rust now. And that's it. You can find that on GitHub if you want to check this out or see an example Tory project for a sort of cross-platform GUI. That is all. Thank you very much.
Thank you very much, Scott. We have a lot of questions for you. So get ready. The first one, do you use Git work tree and what do you think about that?
I don't use Git work trees very much because I use Git Butler, and so most of the time it isn't something that I need. And also we have a lot of build artifacts because it's a Rust thing, and every time you do a work tree, you have to redo the build there, which you don't get if you're sort of stashing branches. So because of the output artifacts, I prefer to use one working directory for stuff, but I do find, a lot of people find it very cool. And I actually learned about it after, I knew it existed, but I learned about it after building Git Butler and then people being like, it's just like work trees. And I was like, kinda. But so I like to educate on it because a lot of people don't even know it exists. I didn't even really know what it did. So yeah, the answer is no.
Okay, then can you configure the blame alias -c in the Git blame VS Code extension?
So I don't use, the VS Code extension that I use for Git is Git Lens, which is a Git Kraken plugin. And I think it's very well done. There is a config setting that you can say, well, for one, you can do the ignore. There is a config setting that you can say when you run blame, run it with these options. I don't know how to find it, but I'm told it is there. So I don't have it turned on. I would like to turn it on. I can't quite figure out how to do it, but I've only spent like 2 minutes researching it. But it does exist, I'm told.
What is the difference between force with lease and using nothing?
Force with lease or using nothing? That is a good question. Using nothing will not, sorry, hold on. Using nothing will not push it if it, oh, that's a great, what is it? Using nothing is essentially will not push it if it doesn't match. No, if it's not in the history of the thing you're trying to push, right? And so if you do like git push, and it sees what's on the server, and then it looks in your history and says, okay, this is upstream, then it'll allow you to push it. If it's not upstream, then it won't allow you to push it. If you do -- force, even if that's true, it will allow you to force push it as long as the last time you communicated with the server, it's just trying to make sure you know what you're doing, right? That you've seen the SHA on there, and that the last time you fetched, it came down, and so you know that it exists, right? As opposed to I don't know that it exists.
Is it true that Linus is working on a new tool to replace Git?
I highly doubt it. I don't think he doesn't seem to care that much about version control these days. Nobody seems to care that much about version control these days. I think everything has been Git for so long. That's kind of why I got interested in the project of trying to rethink what are some interesting things that you can do in version control, but that use Git because the Git ecosystem is so prevalent. But Git is really just a database, right? You can write these commits and trees really however you want. You don't have to use the index and the head and all of the refs and stuff like that. But I don't think he didn't even care about version control when he wrote Git, right? He really just wanted a way to do tarball management easier. So I don't think that's true. There are some really interesting things that are happening in version control world that I'm stealing ideas from for what I'm building, like Jujitsu. If you're interested in nerdy version control stuff, Jujitsu is one of the coolest things out there right now that is from Google, but it's not really prime time, but it's super, super fascinating. And then Facebook has Sapling, which is another nice way of doing sort of stacked patch sort of management.
Okay, then, do you know why GitHub requires force push for amended commits?
All Git servers require force push for amended commits because it's not in the history of the thing that you're trying to push.
After a commit, how can I see the file diffs against origin before pushing them?
How do I see the file diffs against origin before pushing them? Like, what? Okay, you want to know what you're about to push, and so you're on master, and you want to see what's the difference between my master and origin master. You can do git diff origin master ..master, right? And then that will, or maybe it's 3 dots. Does anybody know? Is it 2 dots or 3 dots? I always forget the difference. It's 3 dots, and so it'll say here are my two heads, compare them, but only show me stuff on this side, right? It essentially what it does is try to figure out what's the merge base between the two, and then diffs the merge base, like whatever the first common ancestor is, to the side that's the second argument you give, right? So you could kind of manually, this is what GitHub does by default when you push something in like a PR, is it's not comparing it to the target, it's running back through the history and finding what's the first commit they had in common, and then what's the difference between that one and then the head that's in the pull request. So you can do that on the command line if you want with git diff, origin master ... master. That will give you that. You can also do that with git log, actually, if you just want to see the commits that are on that side, which is also nice.
Okay. Git source code is remotely stored on GitHub. Is GitHub project as well?
Is GitHub stored on GitHub?
It says Git source code is remotely stored on GitHub. Is GitHub project as well?
I'll interpret that. I'm not sure the second part. The Git project is on GitHub, but it's more of a mirror. So the Git project and Linux, actually Linus has his Linux tree on GitHub as well that he uses. At one point, the nicest thing he ever said about GitHub was that it is a not terrible mirror. So, but I don't think they do it in a different way where everybody kind of keeps their own trees. Some of the maintainers or people keep their trees on GitHub. But they collaborate over a mailing list, so they don't use PRs and stuff like that. So they don't really care where it is.
Does Git Butler use a database like SQLite or something, or just Git commands in a nice
So we were using SQLite for some speed up stuff. We ripped all of that out because the complexity wasn't worth what we were trying to do. Right now it's all libgit2 and using the Git database for everything that we want to do. We actually do some interesting stuff that's a little bit difficult to do in Git, and I've seen a lot of people try to do things like this, which is use the Git object database as a database, as like a key value store. The problem is that Git will GC objects that it doesn't see, so everything has to be reachable. So like we have, one of the things that actually our tool has, if you look at our tool. So this is me using, oh, oopsie. Sorry, I can.
Using Discord.
Yeah, that's me using Discord. So this is what the tool looks like. So I can, for example, I have this operations log, so I can see everything that, it's almost like a ref log. It's kind of the history of everything I did. So when I create a branch or move a file or do a commit or, update, sort of like rebase everything onto origin master or any of that stuff, it kind of keeps this thing, and I can then go through and like restore any of them, right? So if I want to go back to what my computer looked like or this project looked like at 7:53 a.m. yesterday, I can hit restore and it just makes everything look like that. It kind of pushes on the top of the stack. So it has this nice operations log. The way that we do this is we keep all this data in Git, right? So we actually have a separate Git tree that stores all of our metadata and the snapshot of the working directory and everything we need to recreate the state. At any time, and then we could push that somewhere if you want, like a backup of your working directory all the time, right? Like kind of pre-commit history. The problem is that if this isn't in a Git ref, so if you run git log -- all, it'll show this if you keep it in a Git ref. If you don't keep it in a Git ref, then Git GC will remove this data, right? Like once it gets too old, which is really kind of problematic. So we do this really dumb trick where we have a ref log for a thing that does matter, and then in like the second part of the history of the ref log, we keep the head of this, right? So you can't really see it. It doesn't really decorate it the way that a branch is, but Git can see it when it tries to GC. Anyways, dumb shit like that can be done in Git. It's a little hard to kind of work around some of the intricacies of kind of what Git does.
How is filter clone different from shallow clone?
How is filter clone different from shell clone? I know all those words individually. Can we skip that one? I don't know what that means.
What do you think about submodules? Do you actually use them?
I don't use submodules. Everybody that uses submodules hates submodules. I use them in some other projects, like I use libgit2 a lot, and that has or I use git2rs, which is the Rust bindings, and that has a submodule to Git libgit2. So I have to deal with them sometimes, but I think if you've ever used raise your hand if you love using submodules. There's one guy, two guys. And look at the mustache on that guy. That is a guy who likes submodules. Absolutely. I would have guessed it. That's awesome. Yeah, I mean, you have to love pain, right? Like, it's just very hard to work with. We actually, right now, Git Butler won't work with submodules because if we see the .git module file, we're like, you can't import this project because we don't want to deal with it right now. There's just too many different things that are really hard to make work right and aren't surprising. And so I know, but there's no other great way, right? There's like subtree merging, or there's like, actually a lot of people just use monorepos for a lot of this now, and try to kind of merge in trees upstream, and use some of the nice monorepo stuff that the Git has now to deal with that. But yeah, there's no great, I'd love to tackle that someday of making a slightly nicer way of doing that. But it's not fantastic in any of the tooling, I don't think.
We have several other questions, but I make you the last one. How many great features of Git are not currently supported by Git guys other than work tree?
By Git guys?
Guys? GUIs.
Oh, Git GUIs.
Sorry.
So some of the, it depends on the GUI. Some of the GUIs support work trees. I think Kraken supports work trees if you want to use that. But most people, honestly, I think most people use Git on the command line mostly, and use GUIs for things that Git doesn't have good user interfaces for, like interactive, like interactive adding, like patch staging and things like that. That's when I would fire up a GUI. That's when most people do. But the thing is that the command line is almost always faster for anything you want to do than a GUI that wraps a button that runs a command line thing. Like, it's almost always easier, and you know exactly what's happening if you're just running the command line thing. So that's why I think most people don't use GUIs. I was interested in building one because I wanted to do stuff that Git doesn't do, but right into the databases, though, it did, right? And so, like, the things that I'm more interested in is what can sort of what can an interface look like that helps the workflow that I want to have, and GitHub can't tell the difference, right? But the way that you actually implement how to create commits and how to create trees and stuff is very different locally. But yeah, I don't know. I don't use any, so.
Okay, so there are other questions, but we have finished the time.
Okay.
I think Scott will stay close by if
Yep.
you need to ask other questions. So please, a warm applause again.
Thank you very much.